don't know when. Oh, I think it goes live once. I think we're live. I think we. Oh no, there we go. Oh, I click live. So what does that mean? I think that means we're live. I thought it would give me a countdown timer to the actual live moment, but I think it means we're live. And Joseph, I think you're for me you're frozen. So I hope you can. I hope you can still hear me. You're frozen at a very good moment. So that's a good picture to be frozen at. So hi everyone. I hope everybody is okay. Please feel free to kind of introduce yourself in the comments and just say hi. My name is Asim Hussain. I'm the Executive Director of the Green Software Foundation and one of the leads of the Impact Framework, which is the main theme of the Carbon Hack, which we're running this year. Joseph Cook, who is frozen currently in the screen. I don't know if you can hear me, Joseph. We are definitely live. Thank you so much. Joseph looks frozen to me, so hopefully he'll come back to us in a second. He is the project manager for Impact Framework. So I've invited him on the call today. So what I'm going to do on this call, he'll joining back. Here he comes. He's back again. Let me add Joseph. There we go. You're back again. Um, so see, I was just introducing. So why don't you say hi, Joseph? Why don't you say hi, Joseph? Yeah.
Sure. Hi everyone. My name's Joseph. I'm a project manager and one of the core developers on the Impact Framework project. And I apologise for the false start there. It counted down to going live, 3, 2, 1, and then sign me out. So
Oh, really?
that's
Oh, well, there you go. We're here now. So, what we're going to do today is very, very, very briefly. We're just going to kind of because we've gone through this a couple of times now, and we've sent the information out multiple times, and we'll keep on doing this every single week. Um, so we're just going to very quickly go over Carbon Hack. Honestly, not even going to spend 5 minutes on it. And the bulk of today's session is going to be just Joseph and myself talking through one of the core concepts of Impact Framework. And this is just something that we're going to be doing every single week now, moving forward, really, for the rest of the year, I suppose, is just sitting and talking about um, uh, Impact Framework, just getting wonky, talking about in core aspects of it, and just working out in the open and discussing. And we also think that's going to be a great way for everybody just to learn a little bit more about what it is, because it is a very new type of project. I got suggested, Joseph, a new name for the show, and it was If Then, which I think is an interesting one because
it's
you got it
good.
right. It's quite good, isn't it? If Then.
Yeah, I
I was
like
thinking
it.
If Else, but that doesn't sound so good. Doesn't sound so good. If Then sounds more positive at least. But we could talk about that. But the so just very quickly, for everybody on the call, talking about Carbon Hack. So Carbon Hack is our yearly hackathon. So we're running in 2024 now. If you, for those of you who might have missed last week's, there's been a date change. We pushed it forward 3 weeks just to give everybody a little bit more time to get things ready. So that's March 18th to April the 8th is the dates of the hackathon. It's all this year going to be about measurement and measuring software using this tool called Impact Framework, which we've been building over the last year at the Green Software Foundation, and it's one of our most popular projects. That we have multiple organisations taking part, quite a few leaders, and just a lot of work happening in Impact Framework. And we're going to talk to you a little bit about what Impact Framework is and kind of how it works. And today we're just going to dive straight into it actually, and just talk very specifically about one of the aspects of it. So it's a hackathon. We want you to build plugins, Impact Framework. We want to. There's going to be prizes for enhancing the framework. You can hack yourself. You can hack with friends. The platform will be announced next week. So next week's Monday session, I'll be taking you through the entire platform. We're basically using GitHub. So everything you're going to do in order to hack is going to be entirely on GitHub. As you'll use your own GitHubs to write your code in, but the actual communication and submitting projects and everything like that, that's all going to be done through GitHub and GitHub issues and GitHub discussions. If you are interested in sponsoring, I can't remember if you've updated our sponsorship. That we've got, I believe, 4 sponsors now for Impact Framework. If your organization is interested in sponsoring, if you've been working on measurement and measuring is something that you're interested in, or a problem that you have and you're interested in maybe nurturing some conversations in that direction. And we recommend, come and sponsor the hackathon. We kept the sponsorship very low this year intentionally, just to bring in just a broader audience in the sponsorship committee. You get to be a judge. You get, obviously normal sponsorship stuff. We promote, give you a logo on the hackathon site, and also we bring you on this call. Like if you've got a specific thing that you want to measure or a specific challenge you have, I actually do want to speak to you. We want to speak to you. We want to find out, what is it? What's your challenge? Let's dive deep. So quick question from Charlie. Is Impact Framework a first of its kind or similar to anything else out there? I think it's the first of a kind. What's one of our challenges that we have in communicating Impact Framework to everybody is that it's fairly new, and it's been built from the ground up just through a year of conversations from people who've been trying to measure software. So it's very much a very different type of tool to other things you might have dealt with, or maybe it's similar. I don't know. I think it's hard for us to really recognize that there's a lot of stuff going on there. It's definitely got very unique characteristics to it. Let me put it that way. And Joseph, if ever anytime, Joseph, you want to dive in, please in answer, please, anything, go right ahead. So we've got a couple of nice, thank you, well done, Moshe. Yes, the green software practitioners course. That's a great thing to get. So we have a couple of prizes. We have best content, we want people to write content, have non-technical contributions. Best model, we're probably going to rename that best plugin, and I'll explain what plugin is. Impact Frame is just a whole load of small plugins. They all do lots of different small things to help you measure emissions. That's the best plugin. We want a prize for Beyond Carbon. We want people to start talking about sustainability beyond carbon, measuring water, waste, other things like that. So there's a prize for that. A best contribution to the framework itself, to the actual command line interface tool. I'm excited to say that we also have a best undergraduate, and now it is confirmed, we also have an under 18s prize as well. So if your entire team is made up of under 18s, then there'll be a prize for you also. It's very important. It's an important value for us to really be speaking to the depth of the experience we have right now. And the people who are under 18s now will be the leaders of our industry in 10, 15 years time. So we really want to help nurture that conversation there. These are the dates. So as I said, 8th of April, hackathon ends, and the closing ceremony is the 18th of April. Last year we ran a very successful hackathon. We had 400 hackers, 51 solutions submitted, and had a number of sponsors from last year, which is a very really excellent prize. If you're interested in sponsoring, just email us at carbonhack@greensoftware.foundation, or even if you just want to find out more information about the hackathon, just email us at carbonhack@greensoftware.foundation, or the website is there's a website. Let me bring up the banner, which is, let me bring it up all the time actually. Here we go. So this is the website go to if you actually want to go to the hackathon website and pre-register. Please, if you're not pre-registered, please pre-register, and then we'll kind of give you lots of information about the hackathon and how to nurture your way through. Just really quickly, I've just got one thing here. So yes, these are the main components of Impact Framework. We have these things called manifest files. So in the manifest files, you put things that you can observe about a running system, be it utilization, be it billing data, be it number of users, website visits, whatever you can observe about your running system, you put it in a manifest file. And what our goal is to find some way of taking that observation and turning it into an impact like carbon. How do you turn utilization into carbon? How do you turn gigabytes downloaded into carbon? What are the steps you need to take? And for that, you need to have plugins. And we've built a set of plugins in the Green Software Foundation which help. And those plugins can take utilization to energy to grid emissions to, and it takes a step by step until you get to carbon. So that's kind of what it's all about. I've spoken about this multiple times. We'll have better videos on this in the future as well. But it's all about plugins, manifest files, observations, and the actual CLI tool is Impact Engine. I'm going to just now flip Joseph to talk a little bit about, we're now actually just going to dive in and get a bit wonky, to be honest with you. and talk a little bit about the actual. Let me stop sharing my screen there. The actual code. So what should I bring up first? Should I bring up? Should I bring up the interface? So there's a couple of things. So when we write these plugins, like what have we done inside Impact Framework? What has been the special thing that we've done? What we've done is we've, I'd say, normalized or standardized the interface to these plugins. Like we're not inventing the wheel here. There's like everything that's been done inside Impact Framework has been done many, 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 many times before in other tools. It's just that when somebody's built a tool to take utilization and turn it into energy, they've written it in whatever language they've wanted to write it in. It's been written using whatever interface they wanted to write it in. They maybe, I always use the analogy of like they use USB-C and you're using Thunderport, and now you have to figure out how to use their model inside your infrastructure. So the secret to building an ecosystem is standardization. The secret to all of this actually is standardization. And what we've done, one of the things we've done is we've standardized the interface to these plugins, and it's actually a very simple. So far, it's a very simple interface. You can see here, it's written in TypeScript, but you can actually write it in whatever language you want. But this is the TypeScript interface. So you just have currently we just have one function called configure. So if you're writing a plugin, you just have to write a function which takes some parameters to configure it. And when this plugin gets loaded up, we'll call configure. And we'll say, this is the configuration somebody gave us in the manifest file for your plugin. Please configure yourself using this configuration. It's up to you how you configure yourself. But that's it. We've just normalized that interface. And the second thing we've normalized is just execute. So when you actually take those observations like CPU utilization or whatever else, we're just saying we're going to pass you those in as an array of inputs. And you just have to give us an array of outputs. And whatever type of model that you are, those are the type of outputs that you give us. If you're the type of model that converts utilization to energy, we would expect these outputs to be energy. And that's it. That's all that we've done. From a function signature perspective, that's it. It's very simple, but we've just standardized the function signature. There were no standards prior to this at all. So we've just provided a little standard here right now, and that's one of the things that we've done. So we're going to be extending this, aren't we, Joseph, in the future? We're going to be adding a little bit more because it turns out we need to expand this a little bit. And I think we need to change some of the language here because we were just talking recently that model plugin isn't the term that we would want to use anymore. We probably just want to stick to plugin as well. So some of this stuff might actually change in the next couple of weeks, but it will all be stable by the time the hackathon starts because we're still in alpha. We're getting to beta right now. So this is just the plugin interface. So when you write a plugin for Impact Framework, you're just extending a class that adheres to this interface. That's all you're really doing. Now, what are these params? Right? We've standardized the actual function signature, but what actually are you going to get passed in to this? What exactly are you going to get passed into your function? Let me stop sharing that screen and share another one then. Let me share. What have we got? What can I share? That's probably a good one. The units. Sorry, what did you say, Joseph?
I was going to say, do you want me to share? Because I have a manifest file and a model.
Go on, why don't you share? Yeah.
Just to follow on from what you're saying.
Yeah.
Hopefully you can see my VS Code.
I have to click a little button, but now we can see it, yeah.
Okay. So, well, you were just talking about the model params and what you actually get passed into one of these models. So here's an example. This is the simplest model that I could think of to show. This is the ENET.
Just zoom in with a Command plus or Control plus. What are you on? Are you on a Mac?
I'm on Linux.
Oh no, you're on a secure.
Hopefully that does it.
Yeah.
So this is the ENET model. This is one of the simplest possible models because all it does is take it is just multiplied by a coefficient. It takes the gigabytes of traffic inbound and outbound and multiplies the total by a coefficient. So it's extremely simple. but it's nice because it can show you exactly what is being passed into the model. And it's here. It's what you pass into the model is an array of objects. Each object contains some fields. Timestamp and duration are required fields, regardless of the model. You always have to have those fields, but the rest of the fields can be model specific. And for this ENet model, we have data in, data out, and this is the coefficient we multiply by. And in the example on the screen, we just have one single snapshot in time. But in a real example, this is just a demo example, but a real example might have 10, 100, 1,000 different time steps so that you can track this over some amount of time at some time resolution. But that is basically what the model parameters, what the inputs is an array that repeats this object for each snapshot in time where you've got metrics for.
Yeah.
And this is what the model actually looks like extended in the interface. So you can see if I just make this a little clearer by moving some of these things around. But you can see how the model plugin interface that you just saw on the screen is actually implemented here. We're extending it in this EMEM model. Our configure function is here. It doesn't actually require any configuration in this model, so we're not really doing anything there. We're just returning the instantiated version of the model. Then we have our execute, and execute is calling another private function down here, calculate energy, where we're just multiplying by the coefficient. And then we're writing a new field back into that back into that object, the array of objects. For each of the objects in the array, we're writing a new field with the return value from the private calculate energy function. And that is about as simple as a model can get, really. We iterate over all the objects in that inputs array. We do some simple operations, some simple calculation on the value of some of the fields, and then we write the result to a new field and return it. And what we get at the end is this same file back, but with a new field outputs, with the new data appended.
And that is kind of like that is effectively what it does. Just to very quickly, there's a question from Adam Coles. How do you see this being integrated into pipelines and live dashboards? Very quickly, I would say Impact Engine is a CLI tool which takes an input YAML file, computes it, and generates an output YAML file. You can parse that, and we haven't built anything. Maybe that's one of the things you could build. Actually, you could build a plugin, which is the last plugin in the pipeline, and so which means that you could then publish it. So whatever data that plugin gets passed, you could publish it to whatever dashboard or anything that you want. And really, it's not something that runs continuously. It's a batch process, so you would need to run it on a cron job maybe every 5 minutes, and then you could kind of compute that and constantly publishing it out. We've seen people. We've had one organization was. Showed us last week that they had a 13 megabyte YAML file because they were computing every single server in their entire infrastructure, and that only took 19 seconds to compute. So it's not really that intensive. It's not really that time consuming. So that gave us a lot of confidence. That's even without any real optimization at this point, any significant optimization. So we're very confident that it can work. Very quickly, I know Joseph showed you a bunch of TypeScript, but everything that we're doing here can actually be done in any language, because we call out to a shell command, and you can write that shell command if you wanted to. We can call out to a shell command, and that shell command can obviously be written in any language that you want. It's just a shell command. It's more performance writing TypeScript, but we can do shell commands as well. So let's dive into the thing we want to chat about today, Joseph. So we've got we've standardized on the function signature, which is kind of one of the most important things, because it's been so hard to compare or contrast any of these models out there because they've all used completely different interfaces. So as soon as we just standardize on the function signature, we were then able to just do like for like comparisons and have the same manifest file like you have, and just have different models and then say, well, hang on, what impacts does it use if we use that model? Okay, I'm going to use the same data, just change the model in that pipeline to a different one. What impacts do we have? So that helped us there. But the key thing is these are those parameters in the observations. You've got data in, data out, network energy coefficient. So like that's the other thing that we're working to standardize or figure out how to standardize is how to actually, what do we do with that? Because other models, like if your model outputs a string, what do other models, like how do we sort that out? Because then if there's 1,000 models out there, everybody's saying like, I'm publishing energy, but I'm spelling energy with a capital E, and I'm spelling energy with a lowercase e, or I'm publishing energy, but I actually want to publish in megawatt hours, and someone else is expecting energy as an input, but they're expecting it in kilowatt hours. So there's this huge problem that we have, not only in standardizing the function signature, but the actual data that's coming in and out. That is a huge problem right now. The number of times there's been issues because people have used pounds instead of kilograms, or some other kind of scaling error than that is quite common. Are you going to show you something, Joseph? I can see you open this up.
No, I was just following along with what you were saying, and I realized that the YAML that I was sharing on the screen was just one single model. So taking some inputs from providing one calculation, and I thought it was a bit more appropriate to have a pipeline on the screen, given that you're talking about translating from some raw data, input, output, traffic, and a coefficient to carbon.
Yeah.
Well, you can't really do that just with the example that I was showing before with the ENet model, but you can do it with something like we've got on the screen here, where we're chaining 7 or 8 models together. Especially because the first one in the set is actually an importer, where we're actually looking up the metrics from an API from a running Azure virtual machine, and everything starts there in that case, rather than some made up data from an example import. It's actually real data from somewhere, and then it's being fed through this pipeline and sort of cascading all the way through with small mutations in place until we eventually get to
Do you want to scroll down to the pipeline? Yeah, if you scroll down to the pipeline there, yeah. There you go. So the way I describe it is like that first input item in the input array gets passed to Azure Importer, which is just a plugin, past the execute function. Whatever that outputs gets passed to cloud input data as an input. Whatever that outputs gets passed to TeadsCare. Wherever that outputs get passed, and so on until you eventually get to the last plugin, and then it just exports it out. And that was one of the epiphanies we had like 6 months ago, I'd say, when we were developing Impact Framework, was we realized we needed a pipeline of models, and that was one of the there were several moments in Impact Framework where we had these kind of breakthrough moments of this changes everything, and that was one of them was when we did realize we needed a pipeline of models, because that now there's so many advantages to having that. Most important being, if you look on the screen right now, this is a model, this is a pipeline which calculates an SCI score. You could replace all those SCI models with a GHG model, which doesn't exist. That could be something that you build in the hackathon. And it still, from Teeds curves, gives you energy. So you would just need to take that energy number and figure out a scope 1, 2, and 3. That would be what a GHG model would give you. But we don't have that. We just use SCI. That's the power of it. You don't have to replace everything. So Joseph, I was thinking through. So we have this. Let me share my screen. Like, one of the things that we've got, and this is something that we actually need to change. I think quite significantly. So the first thing we started to do was, here we go. We started to like maintain this file, which we call units.yaml, which is then just being very explicit, which is then saying if you're outputting carbon, you're outputting grams of carbon. If you're outputting, or if you're seeing a CPU utilization in a parameter, it's gonna be percentage CPU utilization. You're not gonna have to worry about is it 0 to 1 or anything like that. And that way, we're then kind of starting to standardize the inputs and outputs, and that's what you can really. That's how like plugins can really start working with each other. And that's what we started. So energy we've said has to be the string energy, and it's kilowatt hours. Grid carbon intensity, which you know is the grid intensity of the electricity grid, we've said that's got to be the string name, and it's got to be grams of carbon per kilowatt hour. You could write a plugin which doesn't use that or doesn't output that, but it just won't work well with anything else because everybody else is going to expect this. So that's what this is. That's what this is really telling you is like if you're expecting grid carbon intensity, that's the string you should look for, and these are the units it has to be. We've got location, we've got instance type, we've got a whole bunch of different types of ones there. Now the challenge that we're going to get pretty wonky now, and I apologize for that, but we need to discuss this, Joseph and I. So we're going to use this call to discuss it, and we thought it might be a useful thing for you to all see. Is just how do we work? Like how are we figuring this stuff out? I have to stop sharing my screen, present another screen, share a screen. So window, there we go. I made some notes, Joseph.
Mm-hmm.
So this is kind of how we've standardized like the interface to a plugin. We've standardized like the function signature. We spoke about that. We've standardized the units.yaml. I put parameter dictionary because I thought that might make units dictionary. That might be a better term. Units dictionary. We've standardized that. We've shown the function signature, but we're really hitting problems with this kind of units dictionary. Because like, where do we store it? Like, if there's now going to be this one file, units.yaml, and anybody who ever wants to create a model which outputs some value has got to have this units.yaml file changed for that to be of any use, is a bottleneck that's quite significant in terms of development. Kind of some questions there's like so many questions that come into my mind. Like, the future is going to be lots and lots of these models, and therefore there's going to be thousands of these parameters, energy, grid carbon. There's going to be so many of them. Like, how do we choose? Do we just take like whoever's the first person to submit a pull request gets the name? Is it going to be like the Wild West of domain names? Everybody's going to pick like the best name, and then before too long you have to have like 5 word strings for your function names. How do we agree on the units? Like, are we even capable of making that kind of agreement? Like, let's say 50 people want grams and 50 people want kilograms. Like, there's a whole bunch of things there which we need to like figure out. Like, one of the things we've figured out so far is like we should never use an acronym. It has to be a long string, and we've also just agreed on using a hyphen, but that's about it. Do we need a naming convention? To me, longer names feel safer. And I think perhaps if we are going this approach, it should probably be an issue we submit. Like, if you're like writing a model and you're going to be outputting a new parameter that no one's seen before, and you kind of want to reserve that parameter because you don't want anybody else to use your parameter because it's your parameter for your model, I think you should submit an issue. That's one way you can do it. You could submit an issue, and then we have a process inside the core team to review that issue and add it. Although I think we're still going to hit all those issues. Like, I don't know what you think. I think if we had this approach, it will only ever be first come, first served. So pretty much it, wouldn't it? Whoever's first come, whatever units they want, whatever string they want.
I think so. But let's just to rewind and define the problem just a little bit more. The issue that we have is that when we provide this core infrastructure, the impact framework that will take any pipeline of models that's been installed, and from the user's perspective, or kind of from the developer's perspective, you can write a model. You can write a model permissionlessly to do whatever you want and run it through Impact Framework. And to do that, you don't have to touch the Impact Framework at all. You just work in your own repository, install it, and run it. However, that doesn't work necessarily if you're adding a new term or a new parameter that isn't already part of the Impact Framework, because the Impact Framework checks that your units are consistent with what's in units.yaml, which is a file that's part of the core infrastructure. So the situation we found ourselves in is that, yes, you can go and permissionlessly and composably build models externally and load them and run them, but not if you're adding something new, which is exactly what we want people to do.
Yeah,
so
exactly.
Not without making a pull request to the core infrastructure to update units.yaml. So one way that I've been thinking about it is the way that you've explained the Impact Framework to me before is that it's kind of like an executable audit, right? Where you can provide your manifest file. This is an audit of all the, that's just how that was the light bulb moment for me when you were explaining. It's like, okay, it's almost like an executable spec, but it's an executable audit for someone's environmental stack. And in that case,
I really like that term, actually, Joseph. I really like that. I think that might be. I think that's going to be part of our tagline. Yeah, go on.
Yeah. So So you provide your manifest file as your executable audit, but maybe units.yaml has to be part of the model and it's part of the executable audit. You just have to submit it with your manifest file, and in that way, the units that you define, the parameters you defined, are unique to your individual pipeline. But that's all known and re-executable because it's all part of the bundle that you've submitted as your executable audit. But rather than having units.yaml as part of IF, each model has units.yaml, or each implementation maybe has a units.yaml.
That's interesting because I think I was starting to think around similar forms as well. So like, as you were reading, I read a question that came up and I kind of lost track of what you were saying. So you were saying that each manifest file, each audit could have its own units.yaml, which is separate to other ones, just because as long as we're transparent.
Almost like exactly. Almost like you might set an environment variable or something like that to execute your pipeline. Well, units.yaml is maybe just part of that, part of the config for your runtime environment, rather than something that's got to be common to all implementations of the IF because it comes as part of the downloaded.
I see.
Source code.
So when you've created your manifest file with all of your plugins, and you've also have to generate your own units.yaml file.
Maybe we provide a standard template, and then maybe there's even a CLI flag. You do impact engine. Impact engine, impl, and units, and provide a path to units.yaml.
I just want to make sure because there's I apologize, I'm not saying your name correctly. Irate. So has asked, like, can't we find a standard somewhere out there and use it like a NASA naming convention or something? And I was thinking that we haven't really done a full. I suppose that nothing's jumped out. I know there are things out there, but definitely for the things that we've been looking for, we couldn't. There was already discussion and nuance regarding the units for a number of the fields that we have been discussing, which leads us to conclude that there is no clear consensus units, on some of the things we're talking about. But I think that there probably is. We should do something. I like a NASA naming convention. So yeah, we'll if someone wants to do some quick googling and share it, like, let us know. But we'll take a look at that. But from so far, just because of the conversations that we've had, Irene, thank you.
I think the problem is less likely to be not being able to find a standard. It's more like being able to find too many standards and then having to choose between them and being like background to kind of square one.
Like the SKCD one, isn't it? That's the problem, I think. Yeah. I think one of the famous ones I remember is that we use WattTime a lot for the grid emissions data, and I still remember it kind of takes everybody by surprise, but they report it in pounds of carbon per kilowatt hour, and I couldn't even tell you what a pound is. I don't know. But we just assumed it's kilos. So I think there's kind of like there's even an imperial and metrics thing going on here. So there does need to be something there. But just going back to what you were saying, Joseph. So are you saying this? Because what I was like toying around with later on down the line, scrolling on down, I was like, does this need to be a standard, or do we just need to provide transparency regarding the units? And that's kind of like I see you nodding your head.
I'm inclined to think transparency is the primary lever here. But the alternative that I came up with was that you could run with the standard units.yaml, but IF could do some check at runtime to see whether there are any unknown parameters in your pipeline. And if there are, then inject them at runtime. I mean, we already load units.yaml into a JavaScript object. So we could just put some simple logic in there to just push new parameters in, provided they're configured correctly.
Well, I think for me, this is something that I was thinking about as well. Like units.yaml also provides like a really important piece of metadata for a model. It should really, like a model, like you shouldn't have to read the documentation for a model to like understand what parameters it's going to expect as input and to understand what parameters it's going to pump out as output. You shouldn't have to read human written language to determine that. It should be programmatic. I think it should be programmatic. I think when you build a plugin, it should come with its own metadata that says, I'm a plugin. I expect these parameters as input. These are the parameters that I want as input. I am going to, if everything happens okay, I'm going to output these parameters as output, and that's my metadata. We could theoretically then use that to do some static validation or just do some validation full stop. So we can say, oh, you seem to have outputted a parameter that's not in your YAML file, naughty, go away and change your YAML file, because we need a way of like forcing people to maintain this metadata file. And my experience, if there's no error, people don't maintain their metadata files. They just, if they're not forced to, they'll just forget and whatever. So I think there needs to be an explicit error. You're outputting something you've said that you've not told us about. So I think it has to be an all or nothing. I think every single model has to have a metadata file that says what the inputs are, and maybe not inputs. It definitely has to do what its outputs are. That's for sure. Maybe inputs as well. I don't know. Haven't thought that through, but that's one of the things. The CLI tool has to error out if someone outputs, otherwise people aren't going to maintain that YAML file. And then is that all we need? Do we even need our own? That's what I'm thinking now. Like, do we even need to centralize? Like, if we can avoid centralizing anything, that would be a dream. If we can avoid centralizing this power to like I don't know, if we can avoid that would be really, really good. I suppose that the key thing is, what if two people want to use the same name or different units?
Yeah. So the two things that come to mind when you're talking about the first thing is, why can't anyone just choose their own units? Well, because we provide models that will probably break.
Yeah.
They do their multiplication, division, whatever, you're assuming that they've got certain units coming in, and then they go output a certain unit that's predefined. And if someone decides to provide grams instead of kilograms or whatever, then they're going to get some wild number coming back out again. Yeah. So there has to be some standardization of the units for the pipeline to calculate correctly, at least the way we're implementing at the moment. And the second thing is that we use units.yaml for another purpose as well. We've got, for each parameter, we have a field called aggregation method. And the aggregation method defines when we run our aggregation feature, which sums impacts either over time or across different components of the graph, what the right method to do that is. And again, the right value for that is important, and it also requires bit of knowledge, awareness of the nuances of how the aggregation method, how the aggregation feature operates. It's not super complicated, but I can certainly imagine how people could make mistakes in their manifest file on that basis.
I'm alright with people making mistakes in manifest files. I don't know, honestly. I think this is like a manifest file is effectively like a domain-specific language. It's a piece of code, and so they're gonna, there'll be frustrating errors that you make that are equivalent to like missing semicolons, because it's a powerful little thing.
Yeah, but errors that don't throw exceptions,
Yes.
errors that can maybe be a bit hidden.
Gnarly to find. Like
still give you a valid looking output. But...
So just going back to my point that like, imagine a world in which we did not have a units.yaml in the impact framework at all in the slightest. Every model has got to provide its own units.yaml with its own, this is the name that I'm going to output, and these are the units that it will be output in.
Not every model, every execution, right? Because you've got to have some consistency across your pipeline. You got if you've got energy, for example, it can't be in two different units in two different places in the pipeline, I think, because the models are never going to be aware of that.
But isn't that so? When I mean like, I literally mean the plugin, like the plugin code would have to have its own. I feel we're on the same page, but I didn't quite understand what you said, and maybe we're not on the same.
Well,
page.
I feel like if you run the impact framework with a pipeline of models, then there's got to be one global set of units and parameter naming that's consistent for the execution of the entire manifest file, not for an individual model, not plugin by plugin.
Yeah, no, I hear what you're saying, but like, I hear what you're saying, and hear me out. Let's let this thought fully run out, because I think I kind of see why you're then talking about a single file to like that manually maintain. So, what if each model? I do think each model actually should have like a static metadata YAML thing to be descriptive about what it's expecting as an input, as an output. So I think it'll have it anyway. The union of all those YAML files theoretically should be, assuming there's no clashes or anything, the union of all those YAML files will be the equivalent to the global YAML file that we'll need in the CLI to do the aggregation. So I suppose then the question really arises is, in what cases will that unionization of all those YAMLs cause issues? And I think there's two places. Number one, if one model's got energy in megawatt hours, another one's got energy in kilowatt hours, I think we just error out and say, meh, you should rethink your selection of models there. And I think another use case is if two models output. How will you know if there's a clash? That wouldn't even really make any sense. Clashes don't really matter. Do clashes matter? Clashes don't matter. Like if two models output energy, that's actually not a problem. Really, is it? It's not really a problem if two models output energy. It's weird. It's weird, but it's not a problem.
Well, the second model outputs an energy will overwrite the field for the first one, so one becomes redundant.
It does become redundant, but it doesn't become an error. It's just redundant.
Seems like a strange behavior.
It says, but I think. Well, actually, it wouldn't be that strange, because I think that we've not discussed it, but I think there should be like a cascade of models as well. So, like one of the things we were talking when I was at Intel, one of the things because the Intel was going to build a model to measure energy, but that model would only have measured Intel chips. So you would have needed kind of one model above which measured all chips in a rough way, and another model next to it which just does a subset for Intel. So it would both output energy, theoretically, on that one. So that actually does make sense. So I suppose it's if what I've just said is true, it sounds like you can just take the union of all units.yaml of models, and as long as none of them have they can overlap, but as long as the overlap doesn't have different units, that should work. And then in addition to that, I would also say, in addition to that, you could also just explicitly specify a units.yaml file, because like you could then maybe just have it export all of that, and then you can manually review it, and then go, actually, I'm gonna type it in myself and put it that way. But I do think that, like, yeah, I think that might be the solution, because if a plugin does have the metadata about its inputs and outputs, then we could do cool stuff in the future. Like, you've put a plugin here which is expecting these inputs. However, we can see from the outputs of these plugins above it that output doesn't exist. So you're going to have an error, by the way, plugin. So it gives you those options as well, which we're not going to build just yet. So I generally like that. I'm just going to... iReach has just posted a... oh, I can share it on the screen, but I can't seem to actually copy it. I have to type in manually. Hang on. Oh yeah, International System of Units. That is a thing. But I didn't think... Does it give you... It just tells you... Yeah, there is this, but I don't think it covers... It covers, like, grid emissions? Maybe that's the problem, is that there's no international system of units for, like, grid emissions. Or carbon. Does carbon exist there? Hang on. International system of unit for carbon emissions. Okay. There's a statement. There's a Quora that's claiming it's megatons, which is going to be quite challenging when you're.
Yeah, it would be 10 to the minus 11 megatons.
Yeah, every field is going to be 10 to the minus 11. Okay, but hey, I think that's also why I think, like, I actually really like the idea of us not getting involved in the decisions of the units and letting the community decide. So if the community wanted it to be megatons.
Yeah, we just have to make sure that each model plugin can be responsive to the units that are provided by the user, rather than expecting a certain unit in advance, which could be expanding the error surface somewhat.
There could be an ecosystem of model plugins. There could be, like, universes of model plugins which we're the megatons party. So we want everything in megatons, so we just create all in megatons, and then there's the other one that isn't. I'm always very much for the dilution of power. Is usually my my go-to solution. I prefer that to consolidation of power. But anyway, oh, Charlie Cheeseman's asking, can you give me some examples of sort of plugins you're hoping to get built, and will you be matching participants? So great question, Charlie. So I think there's lots of different types of plugins that we'd want built. We will share a bit more kind of next week, I suppose, because once the hackathon platform goes live, it will have a section in there in the discussions area where we've seeded it with some ideas for plugins that you might want to build. For me, in terms of like plugins in general, the way, like if you think of what a plugin enables the Impact framework, it kind of like the Impact framework is so low level. Its power is only the plugins, and every plugin kind of like opens the door to another area or another thing that you can compute. And so I'm really interested in plugins which kind of open the doors to other areas of compute. Like we've been focusing the stuff we've built right now with Joseph. We've just been building stuff to do with cloud computing. We've not really built any ecosystem of plugins that can do like can take like a website, some Google Analytics data, and then compute. We know. I mean, I can guide you if you wanted to build. I can guide you for how to do that. I've got a pretty good idea. But that's like one of the areas is like are there types of plugins which then kind of open up like whole areas of compute. We've built importers. So importers is something that like you can import data from other services. We've built one, or the one's being built by Microsoft team for Azure. If you built one for Google Cloud, for Amazon Web Services, that opens up like an entire like you can door through so many people can then suddenly start using the Impact framework if you kind of build these importer plugins. Joseph, do you have any thoughts on the kind of plugins that you'd like to see?
Yeah, I agree strongly with both of those things that you just said. But there's also there's lots of gaps in our standard library. We only provide a way to measure energy for CPUs, for example. It'd be great to have something that can handle GPUs, or I don't know, maybe even like FGPAs or something like that eventually. I don't know what that looks like personally, but I'm sure GPUs feels like an achievable plugin. I agree with the importers, expanding the importers so we can grab metrics from different providers, not just the big ones either. I think it would be really nice to have like, Hetzner and all these other smaller cloud providers aren't necessarily the big three. There's so much. Even just manifest files for more complicated things like training an LLM or something like that would be really useful. I think it's probably more complicated than it seems, but it also seems something achievable.
I think there's a world, isn't there, Joseph, where like I could imagine some very simple plugins, like a few lines long, like a very simple plugins that are a few lines long, which have taken some information that is buried away in an academic paper. This is this common, what I find is there's so much great studies and findings and coefficients and all these things buried away in an academic paper. And if you could just surface that and then say, hang on, the academic paper is then, that research has then shown that if I have an observation of type X and I multiply it by this coefficient, that generates this impact. I'm just going to make that available in a plugin, and I'm then going to like provide a lot of citations and evidence and really build up trust in this. I can imagine some very simple plugins like that can.
Let me give you a specific example. Like, I came across something great the other day. I found a paper that provided a quantitative link between carbon and liters of glacier melt. So you could, in one small calculation, you could work out how much of a glacier, how much of the world's ice cover you've destroyed by running your application.
Yeah. I love stuff like that. I love how like, what is a gigaton of carbon? Like, what does that mean? And I know there's loads of things with it's equivalent to 43 miles of travel in a car or something like that. There's like loads of those, but even those, they still don't really mean anything. Like bringing it more real. Like, I would love death. That's one of the, I want somebody to write a model. I've been talking about this for a while. I want somebody to write a model called death, which will take some value, and there is plenty of studies out there. There's plenty of information around let's say you take a grid mix. If your grid mix is high, it usually means you're using fossil fuels. And if you're using fossil fuels, the death rate near coal power plants is much higher. And so there are kind of like studies that you can do, which you can say, well, actually, given this impact, we think you're, on the scale of your application, you're probably going to kill 0.5 people, or come up with some metric around that. I honestly do believe if someone created a model, it'd be very controversial, but if someone created a model called death, I don't see there being a very defensible argument with somebody saying we should use this infrastructure versus this infrastructure. It's cheaper, but it'll kill 2 more people. But you know, there's like that, having that kind of conversation, I think is it's real. That's why we're here. But that's what's going on, isn't it? That is what is going on. So or potential future deaths. I don't know where how we want to go down there, but I think there should be something which really brings it closer in line to the issues. Hard for us to sell services to clients to say, well, we've made this really green, and so it can only kill 2 people per week. We could probably say we've killed 1 person less a week. Or if you could probably do something around kind of biodiversity and you know, species protection. There's a variety of things around there, but I think we need to make it much more personal. The impact is going to be much
for
more
me, I'm quite interested in the economic indicators, because there's quite a rich literature linking carbon emission and, say, insurance costs, or cost to GDP and stuff. Those kind of things, which are real, but they're maybe a little bit less psychologically damaging than a death model.
Than a death model. I want to see a death model, but yeah, I understand. But you're right, and I think, but there's also, I mean, it's related to the what was the SEC? You have to file the risk to your financial risk related to climate change. So not your impact on climate change, but your financial risk related to climate change. So like, you know, Facebook's famously got a data center in the Netherlands just 7 meters underwater, as in like under the sea level. So that's a financial risk. So if water level rise, so you've got to like. So there's that kind of financial. I don't know how you can do that from the impact model, but yeah, things like that. Things like that also. Yeah. Anyway. Taking it from death. If I say enough times, someone's going to build it. So, and we'll deal with it then. We'll deal with the fallout then. Awesome. So I think we're coming up to time, and I think sounds like we've actually made some quite interesting progress, Joseph, on the unit stuff. So let's follow up later on. I think let's use.
If anyone has feedback on this sort of stuff, I had it in mind to start working on the units.yaml, implementing some solution next sprint, which means next Monday.
Right.
A fortnight from next Monday.
Okay. Awesome. And thank you, Irit, for your, we'll take a look also at the international system of units. I think if there is a unit, I think we should encourage, if there's a unit that falls onto the international unit, you should use it. My suspicion is a lot of what we're talking about doesn't fall into it. But let's take a look. Yeah. All right. Thank you, everybody. Again, if you want to sign up to sign up to the hackathon, you can go to grundsoft.org/hack/24. We will be sharing next week. We'll be launching the actual platform itself, and like we'll come on and we'll show you how to use the platform and how to actually start signing up and registering your teams. And again, also you mentioned like there's also going to be ways on there where you can post a project idea and say you're looking for a team, and then for them to go and find the projects that are looking for teams. If you don't have an idea, you just want to join a team, you can join a team. Or if you've got a project idea but you need a team, you can just post it on there and we'll help you find a team there. So we'll start sharing that from next week. So awesome. All right, everybody. Right, Joseph, thank you all very much, and good luck for the hackathon, and see you all next week. Bye-bye.
Bye. Bye.